Good day everyone, my name is Arien M. Lopez from Institute of Fisheries and Marine Sciences of Southern Philippines Agribusiness and Marine and Aquatic School of Technology of Davao Occidental. Today I will be presenting the study utilizing alternative carbon source for biofloc system for growth and survival of Pacific whiteleg shrimp, Litopenaeus vannamei. We have already known that fish protein is the most affordable, convenient, and nutritious source of protein in the world. With this, fish global consumption is increasing at 3.1% annually. This is recorded in 1961 to 2017, as stated with FAO 2020. With this high demand, aquaculture firms was put on pressure for higher production. However, maximizing aquaculture produces higher aggregates of organic materials, resulting in toxic effects and long-run environmental risks, as stated by AMAD 2017. Enhancing productivity is the anticipated solution and simplest method in addressing this heightened demand, which is also one of the focal concerns in approving aquaculture, and in particular the shrimp farming. Why shrimp farming? Shrimp farming is a significant contributor to fisheries export, according to Philippine Fisheries Profile 2020 of BFAR. There is 70,474.77 metric tons of shrimp and prawn in the country that is produced through aquaculture. Hence, Biofloc technology is introduced for shrimp farming. Shrimp farming utilizing Biofloc technology exhibits gains compared to traditional fish farming, where there are zero water exchange and more negligible ecological effect. Hence, minimized contamination of the production system, where recycling of the nitrogen compounds generated from the unconsumed 20 to 40% incorporated feeds and converting it into bacterial biomass, which can be used as supplemental feedstock, according to Abnemelec 2012 and Bossier at Ekasari 27. Selection of suitable carbon source is crucial due to the wide range of possible carbohydrate source. You know that each Filipino wastes 2 spoonfuls of rice a day. This is according to Philippine Statistics Authority in 2019 and according to National Food Research Institute in 2021. Bread is included in the 1,717 metric tons of food that is mostly wasted each day. In the dilemma of searching a possible alternative carbon source for the Biofloc technology, study highlights the shrimp culture practices using Biofloc technology through utilizing leftover food as carbon sources. The BFT has been adopted worldwide, and through this research, the local is informed on the technology and a supplementary livelihood opportunity. This result of the study could serve as alternative carbon source on maintaining the biofloc sources, reducing production cost, and at the same time reduction of wastage of leftover food. This study will serve as baseline information to those who plan in adopting biofloc technology on culturing whiteleg shrimp in our locality. The objective of the study is to learn the viability and the possibility of the leftover food, specifically surplus rice and leftover bread, as carbon sources of the biofloc system of whiteleg shrimp on indoor tanks. The specific objectives of the study is to determine the growth performance, the survival rate, and the physico-chemical parameters, and also the feed conversion ratio effects of the biofloc system using carbon sources of leftover bread and and surplus rice. And this is the conceptual framework of the study. For the methods and materials, this study was conducted at Balasinons Loop, Davao del Sur, Philippines. The location has the convenience of available materials and equipment needed and available the laboratory for water parameter analysis. The experimental species used in the study was 150 specific pathogen-free Pacific whiteleg shrimp post-larvae available accredited hatchery from Santa Cruz, Davao del Sur. The Biofloc were inoculated a week prior to the procurement of the experimental species. The experiment was done indoors using 12 cylinder containers, 15 cm in diameter and 15 cm in height, with 5-liter capacity, filled with 2 liters of seawater arranged in complete randomized design. The 4 treatments were replicated 3 times. The containers were stocked with 15 days post-larvae in a density of 6 PLs per liter and were constantly aerated throughout the commercial feeds was utilized following the feeding rates of 3% biomass to 0 to 20 days of culture and 4% of feeding rate to 21 to 40 days of culture. The culture species were fed twice a day. Carbon addition was done every 3 days with the CN ratio of 15:1. Growth measurement was done every 15 days and a decrease of total length and weights were determined. And physical-chemical parameters were monitored daily. And this is the result that has been sold by the study. The growth performance. Among the BFT treatments, the leftover bread has a higher final mean weight and length output. The same trend was observed on the specific growth rate where all treatments is comparable. According to Peter D. Scriver et al. 2019, that complex carbohydrates were in need of more digestion duration. Lesser fermentation time is required. Leftover bread was easier to break down, hence easier to bacterial aggregates and manageable parameters to develop as to compare to the structure of surplus rice and in the combination of the two. This is according to Emerenciano et al. 2017, Foster Powell et al. 2002. Monosaccharides with less protein, lipids, attained best increase in biomass in BFT farming. This can be the reason of low value output from the more complex starch. Highest survival rate of 58.33% was attained by the treatment 1, while the lowest was attained in treatment 2 of 47.22% on Biofloc system with surplus rice as carbon source. But this is all comparable. Highest feed conversion ratio of treatment 2 was obtained in those Pacific whiteleg shrimp post-larvae that were grown on Biofloc system with surplus rice as carbon source. But statistically, there were no significant difference and all treatments were comparable. Simpler starches like leftover bread are simpler to digest and convert into biomass than complex chains of starch. Observed dissolved oxygen and temperature. All of the recorded value during the whole duration of the study were still within the tolerable range, ideal for Biofloc culture, according to Emerenciano et al. 2017. This could be caused by the simpler starch structure of bread compared to rice, which is simpler to digest and attain optimal parameters, according to Adepu et al. 2019, Gomez et al. 2016, and Harvard School of Public Health on 2020. The optimum temperature for the growth and microorganisms around 28 to 32 degrees Celsius that was manifested on Biofloc with leftover bread carbon source. Hence, more microorganisms is thriving on the culture medium as consequences of the greater metabolism. The use of more complex starches cause slow degradation, hence metabolic system affects the parameters of the culture medium. The presence of organic matter from unfermented floc from complex starches gained more H plus ions, making it slightly acidic than others, as to be observed on the leftover bread and compared to the control rice and its combination, according to Adipo et al. 2019, Elsani 2018, and Foster Powell on 2002. But all pH levels are on normal range. While in ammonia, there is minimum variation observed in all treatments during the whole duration of the study, but the values were all within the ideal range of 1 mg per liter according to Emerentiana et al. 2017. The current study shows that the supplementation of different carbon source in Biofloc has no effect on the ammonia levels on culturing whiteleg shrimp. The short duration of fermentation and the complex polysaccharide structure of the carbon source can be the reason. However, the recorded values of dissolved oxygen, temperature, salinity, turbidity, and pH level were statistically significant. And in the conclusion, the use of leftover bread, surplus rice, and the combination of these two as alternative carbon sources for shrimp biofloc system have comparable effect on the growth in terms of length and in weight, survival rate, and feed conversion ratio of the cultured shrimp within 30 days of culture. The leftover bread, surplus rice, and combination of two have significant variation on dissolved oxygen, temperature, salinity, turbidity, and pH, but all values were within the tolerable range. The recommendation of the study are: first, the use of leftover bread and surplus rice is recommended as alternative carbon sources in biofloc system. Second, further investigation for leftover bread as probable carbon source is recommended. And the third is conduct a similar study using a higher stocking density for a longer duration of culture, and other physicochemical parameters is recommended to validate the result of the study. These are the literature cited of the study. And that's all. Maayong adlaw ug daghang salamat. Thank you.